In today's class, we will do some problems on gaseous state. So first question is, the given values are V1 is equal to 2 liters, T1 is equal to 10 to the power of 3 pascals, and T1 is equal to 27 degree Celsius. P2 is equal to 10 power 5 pascals, and T2 is as same as T1. T2 is equal to T1 and V2 is equal to what? This is what we need to find out. So basically here initial temperature and final temperature are same. So temperature is constant. So pressure and volume are only different. Here now we need to apply Boyle's law. Boyle's law is pressure is inversely proportional to volume. So then that will be P1 V1 is equal to P2 V2. So initial pressure is 10 power 3, volume is 2, final pressure is 10 power 5, volume is we don't know. Okay, so 10 power 3 into 2 divided by 10 power 5 is equal to V2. That will be 2 divided by 10 power 2 is equal to V2. So that is 2 into 10 to the power of minus 2 liters is equal to V2, or otherwise 2000 into 10 to the power of minus 2 ml is equal to V2. So that will be 20 ml. The final volume will be 20 ml. This is the first question. Coming to the second question. Second question is 16 grams of oxygen, okay, is present in a volume of V is equal to 22.4 liter at a pressure of 1 atmosphere, and they are asking to find out the temperature. What is the temperature? So amount of substance we need to find out. N is equal to what? So oxygen, 1 mole will be equal to 1 mole of oxygen molecule will be equal to 32 gram. Then 16 gram of oxygen molecule will be equal to 0.5 mole. Okay, so this is the amount of substance. N is equal to 0.5 mole. V is equal to 22.4 liter. P is equal to 1 atmosphere. T is what we don't know. Okay, so as per the ideal gas equation, PV is equal to nRT. Pressure is 1, volume is 22.4, N is equal to 0.5. Our ideal gas equation, the universal gas constant is 0.0821 into temperature. Okay, so then that will be 22.4. If you calculate these values, you will get an answer of 0.04 into T is equal to 22.4 divided by 0.04 is equal to T. That will be 560 Kelvin. Temperature is equal to 560 Kelvin. This is the second question. Third question is at constant temperature, a gas is having an initial pressure of 2 atmosphere. This is the initial pressure, that is 2 atmosphere. And to compress the gas to 1/8 of the initial volume. So the final volume should be equal to 1/8 of the initial volume. The pressure to be applied is what? P2 is equal to what? And let us take V1 as V1. Final volume is equal to 1/8 of V1. V2 is equal to 1/8 of V1. So here pressure and volume are only differing and remaining are all constant. So we are applying the Boyle's law here. Boyle's law. Pressure is inversely proportional to volume. So P1 V1 is equal to P2 V2. P1 is 2 and V1 is V1. P2 is we don't know. V2 is 1/8 of V1. P1 V1 will get cancelled. 2 is equal to P2 into 1/8. This 8 will come here. So 8 into 2 is equal to P2. That is equal to 16 atmosphere. So the pressure to be applied to compress the gas to its 1/8 of its initial volume is 16 atmosphere. This much pressure is required to compress the volume to its 1/8 of its initial volume. This is the third question. And the fourth question is 4 grams of methane CH4 at a pressure of 380 torr and temperature is 273 degrees Celsius, and they are asking to find out the volume. So as per the ideal gas equation, PV is equal to nRT. Pressure is here 380 torr. We need to convert it into, pressure is equal to, we are converting it into pascals. That will be around 50 into 10 power 3. So that will be 0.5 into 10 power 5 pascal. So 10 power 5 pascal is equal to 1 atmosphere of pressure. So I am converting it into 0.5 atmosphere. So the pressure is 0.5 atmosphere. And volume we don't know. N is equal to what? We need to find out. 1 mole of methane will have how much? Here 1 carbon is there. 1 into carbon plus 4 into hydrogen. Carbon is mass number is 12. Hydrogen mass number is 1. That will be 1 into 12 plus 4 into 1. That is 12 plus 4 is equal to 16. So 16 gram. 1 mole of methane will be equal to 16 gram. Okay. So then 4 grams of methane will be equal to 0.25 mole. Right. Okay. So we know the values of P and nRT values we know. Now here the temperature given is 273 degrees Celsius. The given temperature is in terms of degrees Celsius. We need to convert it into Kelvin. So T is equal to 273 plus 273. 273 I am adding here to convert it into Kelvin. So that will be 546 Kelvin. 546 Kelvin. So as per the thing, pressure is equal to 0.5 atmosphere. Temperature is 546 Kelvin. Number of moles, that is amount of substance is 0.25 mole. Ideal gas, the universal gas constant value is 0.0821. Okay, so we need to find out the value of volume. So the formula is PV is equal to nRT. P is equal to 0.5, V we don't know, N is 0.25 and R is 0.0821 and T is 546. So if we calculate this, we will get an answer of, so if we multiply all these things, we will get an answer of 11.2. Okay, 0.5 into V. V is equal to 11.2 divided by 0.5. That will be equal to 22.5 volume. So the volume is 22.5 liters.